Good afternoon. Today we're going to talk a little bit more about naming compounds. That is actually the other way around, writing the formulas from the name. Why is this important? Because we're trying to balance these equations, and we can't balance equations if we don't know the right formula. If we've been trying to get everything on one side equal to the other side, it'll never happen if we have the wrong formula. So today, this video is going to focus on that. Now, everything we're talking about today is old news, meaning we've learned it already. In fact, we covered it in November and December of the school year. However, if you need more examples or you want to see it in print, there are wonderful YouTube videos. I'll see if I can find a few and link them below. Also, we have the textbook itself. So 9.1 covers ions and polyatomic ions. Naming is inside section 9.2. Covalent naming is in section 9.3. Covalent naming is often referred to as molecular naming. I prefer covalent because it explains how they really are, meaning they are covalent. They are sharing their electrons together. And then the last section that shows you how to name is 9.4, which covers acids. So, we have a series of names here. And whenever we have a name, there are several questions that we have to ask. The first question is it an element or a compound? Now, elements feature only one element from the periodic table. Compounds feature two. So let's look at our first problem. Our first problem here is dicarbon dihydride. The question is it an element or is it a compound? Well, it includes two separate elements, so it is going to be a compound. Once we've addressed the fact that it's a compound, we need to figure out, is it covalent, is it acid, or is it an ionic compound? Here's some tricks. If you look at the stair-step line that starts between boron and aluminum on your periodic table, that stair-step line separates metals from nonmetals. Everything on the right-hand side is a nonmetal. Everything on the left-hand side is a metal. Covalent compounds are two nonmetals. Hydrogen is also a nonmetal. Acids have acids in their name, literally hydrofluoric acid, nitrous acid. And then ionic compounds comprise everything else, everything with a polyatomic ion and everything that includes a nonmetal with a metal. So you have two things from opposite sides of the periodic table, not including hydrogen, that are paired together. Another key thing is that covalent compounds include prefixes like di, tri, tetra, penta. All of those are listed in 9.3 that are used to tell you how many. So actually, covalent compounds are the easiest to name. So let's look at this one, dicarbon dihydride. You'll notice that it has prefixes and it's two nonmetals. You have carbon and hydrogen, both of which are nonmetals. So we know that number one, this is a compound because it includes two elements, and it is a covalent compound. And its formula is in its name. So carbon, dicarbon, dihydride. That is the proper formula for that one. Let's look at the next one, potassium oxide. Our question is always, is it an element or is it a compound? It has two elements in it. Because it has two elements in it, it's going to be a compound. So, when we get to our compound list, we have to decide, is it covalent, is it acid, or is it ionic? Well, we can look at it and see there's no prefixes in it, so that means it's not covalent. It doesn't have acid in its name, so it's not acid. So the only thing that's left is ionic. So we know this compound is ionic. Now, to name this one, to name ionic compounds, you have to think about the ions that form. So potassium is in the first column of the periodic table, and everything in that very first column from the left is a plus charge, K plus. Oxygen is in the second to last column from the noble gases. If you think of the noble gases, that helium column all the way to the right-hand side of the periodic table, those are kind of like your zeros. Your negative ones are your fluorine, chlorine, bromine column. Your negative twos are your oxygen, sulfur column. And your negative threes are your nitrogen column. So this oxygen is in the oxygen column, and it's going to be a negative 2. Now, all compounds have a zero charge. They are neutral. So we have to put these two together so that we get something that's neutral. So we'll need two pluses to cancel out the two negative. So the proper formula of this one is K2O. Notice that our final formula has no charges sitting around it. Let's look at the next one, aluminum. Element or compound? Well, this one is an element. There's only one thing there. So then our question is it monatomic or is it diatomic? Monatomic elements comprise most of the elements on the periodic table. However, there are some diatomic elements, and those HON in the halogens. H2, O2, N2, F2, Cl2, Br2, and I2. Well, aluminum isn't any of those, so it is monatomic. And because it's a monatomic element, its symbol is just Al. From this point forth, I suggest that you pause between each question and see if you can solve it on your own. See if you can solve it on your own, and then I'll go over the answers with you. So, our first one here, water. We probably all know the formula for water. It is a compound, but if you want to jump to the chase and just write H2O, you can. By the way, this is a covalent compound. Dinitrogen pentoxide. Why don't you pause the video now and see if you can solve for yourself. Remember, the questions you need to ask are, is it an element or a compound? If it's a compound, is it covalent, acid, or ionic? If it's an element, if it's monatomic or diatomic. Dinitrogen pentoxide. This is a compound. It includes two elements on the right of the stair-step line, so it's covalent. And its name tells me the formula. Dinitrogen, that means there are two nitrogens. Pentoxide, that means there are 5 oxygens. N2O5. Lithium oxide. Element or compound? Pause right now, see if you can figure it out. This one is a compound. Specifically, it is ionic. Lithium is in the first column of the periodic table, so it's going to be an Li plus. Oxygen's in that last column, O2 minus. So that's going to come together as Li2O. Li2O. Let's do a few more. Hydrofluoric acid. Now you may need to turn in your textbook to 9.3 or go to the phschool.com site, pull up our textbook, and to get that textbook you'll need to enter the code CAE in the first book box and 0611 in the second box. That'll get you into our online textbook. From there, you can pull up the textbook and go to 9.3 and you can see the naming scheme for this one. One of the things you learn about acids is that anytime you see hydro in the front, you know that the ion ended in IDE. So it was fluoride and hydrogen put together. This one is an hydrogen plus fluorine put together. So it's going to be HF. Tricarbon octahydride. Element? Compound. You should have figured out that it's a compound. Covalent, acid, ionic. Covalent is the correct answer. So this one is covalent. And again, it tells me the name. Tricarbon octahydride. That means 8 hydrogens. Chlorine. Element or compound? Element. Next question. Monatomic or diatomic? This one is one of those diatomic elements. It's part of Han and the halogens. So its formula is Cl2. ammonium nitride? Element or compound? Compound. Next question. Covalent, acid, or ionic? This one is ionic. So now we need to figure out what ammonium is, and ammonium is NH4. That's one of those polyatomic ions. Nitride, IDE, means that it's one of those ones you need to know from the periodic table. The exception to that is cyanide, Cn-, and hydroxide, OH-. But all the other ones are on the periodic table. So this one, ammonium nitride, if I look at this one, it's in the third column after the noble gases. That means it's N3-. So we have to put together NH4 plus with N3-. I'm going to need 3 pluses to cancel out this 3-. NH4 will go in parentheses with a 3 on the outside, and the N will go by itself. Be very careful. You only use parentheses when you have more than one polyatomic ion. Also be careful that you don't confuse the subscript, the one that is down low like a submarine, with the superscript, the one that's up high. The up high ones are our charges, and the down low ones are how many do we have. You don't want to confuse those two. Lead 3 nitrate. Element or compound? That's a compound. Covalent, acid, ionic. This one's ionic. This is a special one. The parentheses tells you the charge on the lead. Our symbol for lead is Pb, 3+. Nitrate is one of those polyatomic ions that we have to memorize. It's NO3 at the bottom with a minus at the top. So we're going to need 3 of these nitrates. So it's going to be Pb, parentheses, NO3, close parentheses, with a 3 on the outside. Remember that none of our final answers have charges on them. If there's a charge on it, it's wrong. So make sure that your final answer is always neutral and features no charges. Copper 2 nitrite. That has a different ending on it than nitrate. But our first question that we need to ask is, element or compound? This is a compound. Now we have to ask, is it covalent, acid, or is it ionic? This one is ionic. Anytime you see the Roman numeral, you'll know instantly it's an ionic compound. So we have copper, Cu, with a 2+ charge. And we have the nitrate, which we had to memorize, NO2-. That comes together with Cu, parentheses, NO2, with a 2 on the outside. Our last one, nitric acid, element or compound? That one is an element. Our next question, is it a covalent compound, an acid, or is it ionic? This one is acid. We know because it says so in its name. Now, the question that we have to ask now is nitric acid, which thing, quote unquote, is that? Make sure you review 9.3. On the second page of 9.3, there's a nice chart that makes this very, very easy. The other way to remember this is that little acronym that I taught you. And it is something to the effect of, Mighty Mouse ate something icky and he died. So, anytime I see ick, I associate it with the 8's become icks. So, ATEs become icks. And again, this is a little bit clearer if you look at the table when I say it. And so nitric acid, that means that once was nitrate. So I have NO3- paired with a hydrogen, and that's how I get HNO3. Okay, so again, this is just a basic preview, a basic reminder of how to go from those names to those formulas. This is all review. Please feel free to ask questions in class to get clarification after you've watched the video and have tried some old problems back in chapter 9 in general. Again, that acronym is Mighty Mouse ate something icky and he died. MIT is spelled M-I-T to let you know that the "ite" is used with eights. Just continue to look at that chart on 9.3. It helps a lot. Thanks so much. See you next time.